the general multiplication rule and tree diagrams. So and can sometimes mean both and other times mean multiply. All right. So for the multiplication formula, probability of A and B, it's the probability of A times the probability of B given A. For example, if I'm like, what's the probability of drawing a jack and a queen without replacement? Okay. What's the probability of drawing a jack? Okay. And a queen. What would the second one be if I already drew a jack? 4 out of 51. All right. So this is conditional. So you're always allowed to multiply by the conditional probability. So that means you're taking into account what happened first. All right. So the Pew Internet and American Life Project reported that 79% of teenagers aged 13 to 17 use social media, or 79%, and that 39% who use social media feel pressure to post content that will be popular and get lots of comments or likes. Find the probability that a randomly selected teen uses social media and feels pressure to post content that will be popular and get lots of comments or likes. All right, so we would do the probability that somebody, a teenager, 13 to 17, uses social media and feels pressure to be popular. All right, so we would do, all right, 79% use social media. And this right here, this 39% is the conditional probability. So it says 39% of teens who use social media feel pressure. Given that they use social media, they feel pressure. That's just what we plug in for that. Okay, it is the conditional probability. So we literally multiply those together to get our answer, 31%. Okay, so there's a probability that teens use social media and feel pressure to post popular content. All right, let's do some tree diagrams. Shannon hits the snooze button on her alarm on 60% of school days. If she hits snooze, there's a 70% probability she makes it to her first class on time. If she doesn't hit snooze and gets up right away, there's a 90% probability that she makes it to class on time. Suppose we select a school day at random and record whether Shannon hits the snooze button and whether she arrives in class on time. Make a tree diagram displaying this chance process. All right, tree diagrams. These are going to be important, okay? All right, so we start with she either hits snooze or she doesn't hit snooze. There is a 60% chance that she hits snooze. So you'd make 2 branches because she either hits snooze or she does not hit snooze. All right, and we always put the probability on the arrow like that, and then we like put a little box around the word. All right. Now, anytime you do a tree diagram, the second thing is conditional on the first thing. So you can only make a tree diagram when the second thing is conditional on the first thing. In other words, it says, if she hits snooze, given that she hits snooze, right? There's a 70% probability she makes it to her first class on time. So now I'm going to make a tree branch from the snooze button, all right? So there is a 70% chance that she is on time, given that she hits snooze. That means there is a 30% chance she's late. All right, and then they tell us, well, there's a 90% probability if she doesn't hit snooze that she makes it to class on time. So now I branch out again, 90% chance that she's on time, which means what's the percent she's late here? 10. Okay, now after you have your tree diagram, you're going to get some lovely questions asked to you. What is the probability that Shannon hits the snooze button and is late for class on a randomly selected day? So the probability that Shannon hits the snooze and, so use your and symbol, is late. All right, now this means we are going to multiply. So our little formula that we just learned is we multiply the probability of the first thing times the probability of the second thing given that the first thing has happened. All right, so when we do and, it means we are going to multiply one times the other, meaning I'm just going to track my path. All right, snooze is 60%, and the probability of being late then is 30%. So I just do 60 times 30. So that second one, late given snooze, is the 30%. All right, and I get 0.18 for the probability she hits snooze and is late. All right. What is the probability that Shannon is late to class on a randomly selected day? Okay, so the probability of late. Now, there are two ways to get to late. All right. One pathway is she hits snooze and is late. The other pathway is she hits no snooze and is late. All right, one or the other. So you multiply as you go across, okay, because it's this and this, but you add the different methods of getting there. So I'm going to do 60 times 30%. She hits snooze and is late, or is a plus sign. The other pathway to late is 40% times 10%. All right, that's the other pathway, and we get 22% chance that she's late. Okay. All right. Suppose that Shannon is late for class on a randomly chosen school day. What is the probability that she hits the snooze button that morning? This is a given statement. All right. So this is what we learned yesterday. So suppose that Shannon is late for class. What do we know happened? All right. Notice I'm using the given statement here. Okay, she's late for class. What's the probability that she hit the snooze button? Here's where we are going to use the formula. All right, we don't have a Venn diagram, we don't have a table. Well, actually the Venn diagram would be the formula, but we don't have a table. All right, we have this lovely chart. So my formula for the conditional would be snooze and late divided by the probability of late. I actually just did both of these pieces of the formula above, right? But I'm going to rewrite it just for fun. Okay, snooze and late means I multiply the 60% times the 30%. Okay, and then the bottom is all the pathways to late. So there's 60% times 30% plus 40% times 10%. All right, or yes, you could use your work from above. I'm just reiterating the formula. Okay, final answer would be 82%. Okay, so that means given that she's late, there's like a pretty high chance she hit the snooze button. All right. I don't think you need to write this down, but let's read it. Okay, a tree diagram shows the sample space of a chance process involving multiple stages. The probability of each outcome is shown on the corresponding branch of the tree. All probabilities after the first stage are conditional probabilities. So maybe in your notes, just circle this little piece here. These are all conditional, right? Based on whether or not she hit snooze. So anytime you're doing a tree diagram, whatever you're putting in those second branches, those must be conditional on the first branch to make a tree diagram, okay? Okay, we're going to do another one. Video sharing sites led by YouTube are popular destinations on the internet. Let's look at only at adult internet users age 18 and over. 27% of adult internet users are 18 to 29. All right. Another 40% are 30 to 49. And the remaining 28% are 50 or over. The Pew Internet and American Life Project finds that 70% of internet users age 18 to 29 have visited video sharing sites. okay? And 51% of the middle age group there, and then 26% of the old people have visited video sharing sites. This is before TikTok. It was like just YouTube, I think. But here we go. Draw a tree diagram to represent the situation. So how many branches does the first little part have? Yeah, they split up the age groups into 3, all right? So my first part is boom, 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 okay? So the age groups they did were, let's see, 18 to 29 is 27%. Boop, 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 27%, okay? And the next one, we've got 45% are 30 to 49. My middle-aged people. All right, and my last little part, we've got 28% are 50 and over. All right. Okay, from that little piece where I split up the age groups, it says that 70% of internet users aged 18 to 29 have visited a video sharing site. How many branches does each of these need? 2. Yeah, you either visited YouTube or you did not. All right. So of the young people that actually use the internet, 70% have visited. I'll put a V. Okay. So what percent have not? 30. No visit. Be lazy there. Okay. All right. And then of my middle-aged people, they're going to give us another percent here. 51% of the 30 to 49-year-olds. So I'm going to put a 51% have visited, which means that 49% of this middle age group have not visited. All right. And my old people, 26% have visited, which means that 74% have not visited YouTube. Okay. So you make your tree diagram. That's part A. Boom. Find the probability that this person has visited a video sharing site. So for part B, we would do the probability of visited. How many pathways to visited are there? 3. There's this one, and this one, okay? So you multiply down your pathways and you add the different ways, okay? So I'm going to do this times this. So I have 0.27 times 70%, okay? And then I'm going to do the next pathway to visited, which is the 45% times the 51%. And the last pathway to visited is 28% times the 26%, all right? And we would plug that in and get 49%. All right, part C. Given that this person has visited a video sharing site, find the probability that he or she is aged 18 to 29. Okay, this is my given statement with the formula, which it usually leads up to a problem like this or a question like this, okay? So probability of, and we do our little given statement, okay? So what goes in the second spot? What do we know happened? They visited a video sharing site. Find the probability that the person is 18 to 29. I should use a better variable for that because my formula is going to look funny, but whatever. 18 to 29 and visited divided by the probability of visited. All right, in the top, what 2 numbers should I multiply together for the and statement? Exactly. All right, the top means I'm multiplying this times this. Now, in the bottom, I just did that piece, right? The probability of visited is this number right here. Instead of rewriting it out this time, just going to put it there, okay? All the pathways to visited go in the bottom, the probability of visited. And you would get a lovely answer for that, okay? I'm going to do another one, even if you're tired of this, because this one's just really interesting. Probably should have skipped the YouTube one because that was kind of boring, but whatever. We're going to be really good at tree diagrams, so let's practice another one. All right, we've got many women have annual mammograms to screen for breast cancer after the age of 40. A mammogram isn't foul-proof. Sometimes the test suggests that a woman has breast cancer when she really doesn't. That is called a false positive. Other times the test says that a woman doesn't have breast cancer when she actually does, which is a false negative. Suppose that we know the following information, all right? 1% of women aged 40 or over in this region have breast cancer. For women who have breast cancer, the probability of a negative mammogram is 3%. For women who don't have breast cancer, the probability of a positive mammogram is 6%. All right, what do you think my first branch is going to be? What? Yeah. Okay. So they either have it or they don't. All right. So have it is 1%. So 99% do not. All right. Now, for my next one, it says, for the women who have breast cancer, the probability of a negative mammogram, which is bad because these people have it, right, is 0.03. So I'll do negative and positive. All right, which is 97% get a positive, as they should, right? We would like to flag these people. All right, so then in the next one, 90%, 99% do not. And it says that for women who don't have it, there is a 6% chance of a positive test, which is wrong, all right? Positive. All right, so then what's the chance of a negative? Okay. All right, so now it says, a randomly selected woman age 40 or over from this region tests positive. Find the probability she actually has breast cancer. Okay, so this person tested positive. Find the probability she actually has breast cancer. What goes second? Positive. Okay, we know she tested positive. What's probability she actually has it? I'll use H for that, all right? So probability of H and positive divided by the probability of positive. What goes in the top? What two numbers am I multiplying, you guys? All right, there you go. All right, has it times positive. And the bottom is all the pathways to positive. There are two pathways. So I'm going to do 0.01 times 0.97 again, plus the other pathway to positive, 99% times the 6%. Okay? And when you plug that in, you get 14%. Pretty crazy, you guys. What is this actually saying, you guys? The probability that she actually has breast cancer given a positive test is only 14%. Isn't that weird? Seems weird. Thought that was interesting. All right, there you go. Tree diagrams. Let's try this problem first. What is this? 5.3b. All right, guys, let's check quickly what you wrote down. Okay. Probability of stats, 59%, whatever you rounded to. All right. So you want to do all the pathways to stats. So this times this, plus this, times this, plus this, times this. All right, and then the conditional piece. So Lakeville and statistics divided by the probability of statistics. So in the top, just multiply Lakeville times statistics. I probably should have written those two things I multiplied by, divided by the 59%. You get about 46%. Any questions? All right, go ahead and pass that over.